Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Datawaves. We're going to be talking about how to migrate Hadoop workloads to AWS with Dremio. But again, just a reminder, you can get your hands on the Data Lakehouse to try it out with no cost, no obligation by heading over to Dremio Test Drive. Just head over to dremio.com, click the test drive button, and well, you're off to the races. And also make sure to pick up an early copy of O'Reilly's upcoming book, Apache Iceberg, the Definitive Guide. Okay, slated for release early next year. Just scan that QR code right there to get an early copy. Again, every few months we will be updating that early copy as chapters get completed. So basically, always make sure to check in on that QR code every once in a while for updates. Also, we got plenty of episodes here at Gnarly Datawaves coming up. Okay, next week we're going to be going with Memorial Sloan Kettering and talking about how they use Dremio to help accelerate cancer research and save lives. After that, we're going to be talking about what's new in the Apache Iceberg world, so new features, new aspects of the Python API, and so forth. Then the week after that will be machine learning, experimentation, reproducibility on a lakehouse, learning how to use things like a Nessie catalog in order to be able to have reproducibility, have that experimentation, so that way you can have effective machine learning in your data lakehouse. And then we're going to have another presentation on June 20th, which is Dremio and the Data Lakehouse table formats, where basically this one will be one I'm presenting where I'll be going over what are the different table formats. So again, reintroducing what's Iceberg, what's Delta, what's Hoodie, and just talking about the different stories of how you can use them with the Dremio platform. But so lots of great episodes on the way. But also Dremio will be throwing all these events with AWS and Tableau. So if you're in New York, Chicago, Toronto, on any of these dates, make sure to go attend the event. It's going to be a good time. And we'll also be at all these events across the world, whether it's Data Festival, Big Data London, Big Data and AI Paris, Coalesce by DBT, etc. So make sure you don't miss any of the fun to come. This is Alex Merced, and we're going to continue on to our main presentation. We'll be talking about the best practices for modernizing Hadoop workloads on AWS with Dremio. Okay, so we're going to be introducing our panelists for today, which is going to be Jorge A. Lopez, product specialist for AWS, and Jeremiah Morrow, director of product marketing at Dremio. And the stage is yours.
Hi, everyone. My name is Jeremiah, and I'm a product marketing director for Dremio. And I'm joined today by Jorge Lopez, product specialist for analytics at AWS. And we are going to talk about best practices for modernizing your data architecture with Dremio and AWS. Here's a quick agenda for the next 30 minutes or so. First, Jorge is going to talk about the rise of data lakes, and he'll talk about some of the challenges that organizations have faced over the years with HDFS. Then he's going to talk about object storage and some of the features that make Amazon S3 a good fit for your data lake storage. Then I'll go into a quick recap of what is Dremio, and then I'll talk through a step-by-step approach to modernizing and migrating your analytic workloads to the cloud. I'll recap with a couple of benefits, and then I'm going to share a customer story. We should have plenty of time at the end of this for Q&A, so feel free to submit your questions throughout the presentation. You don't have to wait until the end. So now I'm going to hand it over to Jorge to talk about data lakes. Jorge, over to you.
Thanks a lot, Jeremiah. So Jorge Lopez here, principal specialist for analytics and storage at AWS. So we've all heard about how data has become the most valuable asset for organizations and a source of competitive differentiation. But how did we get there? And how can organizations make this a reality? Well, at the beginning, there was the enterprise data warehouse. And for those who have been in the space long enough, you may remember the corporate information factory by Bill Ayman. Back in the day, you will have some gigabytes of data, and maybe the most sophisticated data warehouse is scaling to hundreds of terabytes of data, mostly coming from sources that are transactional and structured in nature, things like orders, inventory, payments, and you will have a large staging area, right, where you would aggregate this data, normalize it, transform it to fit a specific data model, and then you will load it into your data warehouse. This approach worked well. However, it was limited to highly structured data, and you will have a very rigid data model. And what that meant was that users often had to wait a long time, sometimes even months, before they could get their reports, or when making a change, like adding a metric or a KPI. And what happened is that because of this, individual groups would build their own kind of departmental data warehouses, which created data silos and prevented companies from getting a full view of their data. And these are some of the challenges that brought Hadoop into the picture. So what is Hadoop? Hadoop is an open source framework that provides distributed processing of large data sets across clusters. This framework was specifically designed to scale by clustering thousands of machines together. Each machine were to have like their own local compute and storage resources. Originally, the storage layer was provided by HDFS, the Hadoop file system, and the compute by MapReduce, the processing engine. Today, we have a number of processing engines. The most popular is probably Spark. So some of the cool things about Hadoop were that Hadoop made a whole bunch of quote-unquote cheap servers look as highly available and scalable supercomputer, right? The framework supported all types of data and still provides a different approach in which you define the schema on read. So it's kind of on the fly, if you will. And this in turn make it technically and economically feasible for many organizations to store and process extremely large data sets, including structured, but also semi-structured and unstructured data. So many organizations moved to adopt Hadoop and started to build data lakes based on HDFS. But as Hadoop went mainstream, deploying and maintaining Hadoop became a full-time job, right? So things like, well, you have to set up and maintain lots of hardware. Remember all those nodes that I talk about? It's commodity hardware. Well, even if you only have a few hundred nodes, chances are disk drives, network cards, CPUs will fail very often. Scaling Hadoop can also take time. So the way Hadoop works is, each node has compute and storage, right? So if your data grows, you cannot simply add more disk. You have to add complete nodes. This means you have to redistribute the data, and this process can really slow you down. And one other thing is that you kind of lock your data into HDFS. If you need your data somewhere else, you still need to do complex ETL processes. So on-premises Hadoop didn't make it any easier to share the data. And that meant that data silos continued to be a problem, along with all the cost of maintaining and deploying these clusters. And that's why today we see organizations moving away from traditional on-prem Hadoop deployments and onto modern architectures with a data lake on the cloud. And the way we define a data lake, at least at AWS, is not as a single tool or a single silver bullet, right? We define it more as an architectural approach. And is one that allows you to store massive amounts of data into a central repository. So it's readily available to be categorized, processed, analyzed, and consumed by diverse groups within an organization. A data lake allows you to store virtually any type of data you need and run analytics on top of it, including advanced data science and machine learning. Now, a data lake on the cloud has many benefits, including, first of all, decoupling compute and storage. So you can scale each of these resources independently, right? In most cases, you can analyze data in place, which means you don't have to store and maintain multiple copies of the same data. You can also use the best tool for the job at hand, and I will talk a little bit more about that. And last but not least, you only pay for what you use. So if you think about it, the data lake played a very important role in terms of allowing companies to innovate. Innovation depends on experimentation. And because of these characteristics that I talk about, organizations can very easily run an experiment, take the learnings, shut the infrastructure down, and move on to the next experiment and pay only for what you do. Now, the first thing to decide when you are modernizing your on-prem Hadoop and moving to a data lake in the cloud is where to store your data. Ultimately, the storage layer is going to be kind of the data fabric of your architecture, right? And so you should look for specific capabilities that are provided by storage services, including, and I'm just going to name a few. Number one, making all the data directly accessible to hundreds of analytic services. So customers can use the best tool for the analytic job at hand. Number two, fast performance. You want to support interactive querying, machine learning, real-time analytic workloads, and so on. Number three, security. Security is very important. You need granular security, data governance, auditing capabilities to see access patterns, who is accessing what data for what purpose. You also need the ability to store and consolidate any kind of data from fully structured to fully unstructured data. You need the ability to easily move the data, to ingest the data, but also to share data sets at scale from different sources, including offline and online, and share it across very diverse groups, so your data lake doesn't become another data silo. And obviously, last but not least, you need the ability to automate cost savings based on usage patterns. So then you can reinvest those savings to fuel more innovation. And Amazon S3 is really a good solution on many of these fronts. In terms of scalability, S3 holds more than 200 trillion objects and averages over 100 million requests per second. For security, S3 offers a variety of encryption options from server-side to client-side encryptions. In terms of cost, if you think about it, a typical Hadoop deployment stores 3 copies of the data on HDFS. This means you are paying for 3 times the storage. On the other hand, Amazon S3 is designed for 11 nines of durability and 99.99% availability. So you only need to store 1 copy of your data. And that's why we see the large majority of customers building data lakes on top of Amazon S3. Now, again, as data lakes on the cloud gain more adoption, what we see is that customers are demanding or desire capabilities that are more associated with database systems, things such as ACID transactions, the ability to adapt to constant changes in the schema, time travel capabilities, data compaction for performance improvements. And they also want to avoid a kind of lock-in, right? So one of the nice things about using Amazon S3 as the storage layer for your data lake is that you can store the data on the format that you want, or the format that is more optimum for the specific task that you want to accomplish. So for instance, Parquet is a really good open format for analytic queries because it compresses the data, so you save more on storage, and also it provides fast query response time. And also open table formats are very desirable because they provide all those capabilities I talked about. One of them, Apache Iceberg, we've seen a lot of traction and adoption from customers. Similar to storage, analytics is not a one-size-fits-all proposition, right? That's why we provide a very broad set of services that can help you use kind of the best tool for the job, from SQL queries to Spark to search, real-time analytics, business intelligence, machine learning. All of these are tightly integrated with S3. And of course, we have thousands of partners like Dremio that are tightly integrated and can provide a very broad set of analytics. So now that you've consolidated the data silos, you also need to think about further opportunities to optimize costs. So again, you can continue to reinvest those savings to fuel innovation. And that's where Amazon S3 Intelligent Tiering comes into play. S3 Intelligent Tiering automatically stores objects in 3 access tiers: a frequent access, an infrequent access tier with 40% lower cost than the frequent access tier, and an archive instant access tier with up to 68% lower cost. And the way this works is S3 Intelligent Tiering automatically moves the data to the most cost-effective access tier based on access frequency. And it does that without any performance impact or operational overhead. So for example, objects not accessed for 30 consecutive days are moved from frequent to infrequent access tier. Overall, this means that you can use S3 Intelligent Tiering as the default storage class for virtually any workload, especially data lakes and analytics. Also, we'd like to talk a little bit about the S3 storage lens. This is very useful if you think about moving HDFS data to S3. One thing you want to make sure is to have organization-wide visibility into S3 usage and activity trends, right? And that's what Storage Lens provides. It makes actionable recommendations to implement data protection best practices and improve even more cost efficiencies. So let's say you have data that is not encrypted. Storage Lens will let you know. So that way you can take action. And it's very easy to activate from the S3 console. So now that you have kind of hopefully this provides you a kind of a picture of some of the considerations when you are moving that HDFS data to the cloud and start building the foundation of your data lake. Now let's hear from Jeremiah how you can leverage Dremio to modernize those Hadoop applications and get more agility and cost efficiencies with Dremio and a data lake on AWS.
Thanks, Jorge. Now I want to talk about building a Cloud Data Lakehouse so you can take advantage of all of the capabilities of Amazon S3 and the AWS ecosystem. And I'm going to start by recapping a little bit of what Jorge was talking about with this architecture, which is what we see in probably 99% of enterprise organizations today. And this was sort of inevitable based on the history of data architectures that Jorge shared. Customers adopted Hadoop to solve a very real storage problem, and it did that. But it never replaced fully the EDW's BI and reporting capabilities. So what we ended up with is this 2-tiered architecture with data warehouses sitting alongside one or more data lakes, and they're generally doing what they've always been good at. So you see BI and reporting done in a data warehouse, and data lakes are the place where data scientists work. And if a BI user needs an important source of data from the data lake for a report or a dashboard, the data team would have to move that data into the warehouse via some sort of ELT or ETL process. Those processes can often become a bottleneck that makes it really difficult to quickly give data consumers access to new data sources. And on the other side, on the presentation side, users often build BI cubes and extracts to meet their performance SLAs. And so there are multiple copies of the same data floating around your organization. All of this translates to a lot of complexity and management overhead, especially as those semi-structured and unstructured data sources become the most critical sources of customer and operational data that your data consumers need access to. So Dremio's argument is this: simplify access to all of your data with a high-performance query engine, with a no-copy architecture, and a self-service semantic layer. Dremio sits in between your data sources and your end users. It gives your data team a really easy way to centralize management and governed access to a wide range of data sources, both cloud and on-premises. Users can join and query data from data lakes, from relational and NoSQL databases, all without moving or copying data. And they can connect to their favorite tools for BI and dashboards. Dremio is based on an open source project called Apache Arrow, which is an in-memory columnar distributed query engine. And then we added query acceleration technology in the form of reflections, which is essentially a materialized view that makes your queries much more performant. The semantic layer is a user-friendly abstraction layer that caters to both really technical users and also non-technical data consumers, so more people can get access to data really easily. And all of this is done without creating physical copies of the data. So that's a high-level overview of Dremio. But we know from a lot of conversations that getting to the cloud can be intimidating for a lot of organizations. Very few migrations happen overnight. Meanwhile, you have to ensure business continuity throughout your migration. Maybe you're ways out from a hardware refresh and you need to keep using your on-prem infrastructure while you're paying for it. Maybe you don't think you have the cloud skills in-house. And there are probably a lot of other reasons that I haven't named. So the question is, how does Dremio alleviate some of those issues and empower your organization to move to the cloud and specifically to AWS? So let's go back to this architecture and let's start by adding two components, Dremio and Amazon S3. So the first step is to stand up your Amazon S3 data lake and sign up for Dremio. With Dremio, you can connect to all of your existing on-premises data sources as well as your Amazon S3 bucket. Nothing's really changed on this step. Nothing has to change about the way that you're doing things now. You don't need to move any data over until you're ready, but you can start exploring data in your data lake and in your data warehouse with Dremio. You can connect to your BI tools and you can run some ad hoc queries or recreate a dashboard using this architecture. The next logical step is to start populating your data lake by pointing new data sources to your Amazon S3 bucket. Again, nothing about your on-premises environment or workloads need to change. If you have an executive dashboard that you need to run and continue running that's mission critical, that can still run exactly how it always has been. Dremio still acts as a self-service access layer, joining both your Cloud Data Lakehouse with your new data sources, with your on-prem data lake, as well as your data warehouse environment. So nothing is impacted at this point in terms of your production workloads. The next step is that we start moving data from on-premises sources into your cloud data lake. And you can prioritize this however it makes sense for your organization and your specific analytic workloads. But the key here is that this doesn't have to happen all at once in order for you to continue to get the analytics, serve your dashboards that still need to be loaded. So you can move this on a workload by workload basis, prioritizing ones where cloud makes the most sense. Examples of this would be a dashboard that runs seasonally, where you can take advantage of elastic compute for cost savings, or data sets where you need workload isolation because maybe a lot of different users are hitting the same database. Or if there's a workload where you want to leverage other AWS services, which is something that I'll talk about in a minute. Those are all really good candidates for migration. Eventually, as your organization gets more confident and more workloads move over to Amazon S3, you might consider consolidating your data in a centralized data lake in AWS. And you can leverage this very simplified architecture to store and query multiple types of data, structured, unstructured, semi-structured. Ultimately, this is an example of an ideal end state, and results may vary. Ultimately, whether a centralized data lake makes sense is completely up to each organization. When you get to the cloud, though, you're going to find that Dremio plays really well with AWS. AWS is a great partner. We've done a lot of work to make sure that you can use other AWS tools alongside Dremio. We obviously connect to Amazon S3. We can also connect to other data sources in the cloud, including Amazon Redshift. If you want to access and augment organizational data with third-party data, you can use AWS Data Exchange, and we have customers who are doing that today. We did a blog post with AWS Transfer Family last year to show how you can build a data lakehouse on AWS using AWS Transfer Family to actually populate your data lake. And then we work with tools like Cloud Lake Formation and AWS Glue to help you build and manage your data lake and all the data that you store in Amazon S3. Then on the presentation side, we work with SageMaker for data science, and then we have a connector to QuickSight coming very soon. So here are a couple of benefits to taking this modernization and migration approach. First, you can ensure business continuity. You can start modernizing and migrating to the cloud while ensuring continuous data access. You don't need to disrupt existing workloads or access to mission critical data to begin to go down this process. You can start immediately. You can transition workloads as it makes sense. The second is instant data access. I've talked to a lot of companies over the past several years, both at Dremio and elsewhere. And the numbers that I've heard most often for this type of project are 3 to 5 years. I had a data architect for a financial services firm in Chicago tell me they're on a 3 to 5 year journey to build a centralized cloud data lake. None of their users can wait 3 to 5 years to access all of their data in a unified way. So this approach enables nearly instant access to a unified view of your data, so your data consumers don't have to wait. And the third benefit is getting cloud skills today in a way that lets your team and organization grow with the solution. So there are a lot of benefits to be found in the cloud and using cloud data analytics, and you don't have to put off testing this architecture out and starting to build the muscles to be efficient with cloud management. Ultimately, to summarize all of this, the most common word that I've heard from customers is confidence. They have confidence that a move to the cloud won't disrupt their business. They have confidence that they can provide data access to their consumers in a fraction of the time, and confidence in their ability to manage and deliver cloud analytics immediately. So before we get to Q&A, I want to talk about the Hartford. This is one of our customers that has gone through this transformation. They're a financial services organization specializing in investment and insurance, and they were founded in 1810, so well over 200 years old. They're a Fortune 500 company based in Hartford, Connecticut, hence the name. And their goal was to be able to combine data from on-premises sources like HDFS and Oracle with data in cloud sources like Amazon S3. They chose Dremio for our ability to easily combine data from all of those different sources using simple SQL statements to create a virtualized and unified view of their data without copying that data or moving it around. With Dremio, they found it really easy to access and query data in place from a variety of sources, including cloud sources like Amazon S3, Amazon Redshift, Amazon Elasticsearch, and on-premises sources like HDFS and Oracle. They leveraged reflections and realized significantly accelerated query performance, even on really large tables and files. And ultimately, Dremio also offered improved functionality over their previous query tools. So what the Hartford was able to do was deliver access to a unified view of their data across multiple cloud and on-premises sources, and leverage the cloud flexibility and scalability for all of their analytic workloads. So that concludes the formal part of the presentation. I believe we have plenty of time for Q&A. So let's kick it over to Alex Merced to get that Q&A started.
Welcome back to the Q&A portion of today's adventure. Hopefully you guys enjoyed what was a phenomenal presentation, okay, from Jorge and Jeremiah. Thank you very much, guys. And now we're going to go through some questions we have for them. So first question I have is, we have a large Hadoop cluster in-house. Okay, are there any tools to move the data into S3? I'll send that one over to you, Jorge.
Yes, thank you, Alex. So yes, there are plenty of tools that you can use for that, and we can definitely help. One of them, like, it depends on the amount of data and also the type of connection that you have. But most customers normally would use data sync. It's a tool that you can use for online transfers of data, and it supports HDFS. For really large migrations where online connectivity is not ideal, you can use the Snow family. But those are two of the most common options. And of course, we also work with a ton of partners like OneDisco, for example, that can also help in the migration.
Awesome. Okay, and our next question is, how long does it take your customers to go through this modernization? That can go to either of you, whoever wants to take that one.
Sure, I can start with what we typically see, and also with a couple of caveats. First being, every migration is and modernization project is completely different. So just like I said in the slide, what does your end state look like in terms of how long it takes you? Results may vary. But I saw on the poll, a lot of customers or a lot of people on this call were worried about business continuity. And once you stand up a Dremio environment and connect to all of your on-premises sources, and your executives see that they can still get their dashboards, that they still have access to their data wherever it is, that builds a lot of confidence. And so we typically see migrations go from years to months. So significantly shorter once they have that experience.
Awesome. Okay, next question. What encryption options does S3 support?
I'll take that one. Yeah, so in general, we support encryption both at rest and in motion. There are plenty of like flexible options. We support server side, client side. We allow customers to manage their own keys, or you can also use services to manage the keys. And also by default, like if you don't choose any encryption option, S3 by default will encrypt now all your data, and that started recently. Yeah, I mean, there are plenty of options.
Awesome. Okay, next question. Is Dremio still fast when querying multiple sources, i.e. on-prem and cloud?
Yep, absolutely. And that's a question that we get. I think we got that on another webinar around data mesh. So Dremio features a lot of query acceleration capabilities that you can take advantage of. So that it, including reflections, which is essentially a materialized view that enables you to optimize how the data is read for a query. And so those are some of the advantages over solutions like data virtualization, like a Denodo, for example, where you're not actually, a lot of those customers still have to make data copies to ensure performance. We enable fast performance and joining and querying data across your environment without making copies.
Awesome. Okay, next question. Does S3 provide strong consistency for Jorge?
Yeah. So yeah, I understand where that's coming from. In the long time ago, on S3 that wasn't the case, but yeah, I mean, now Amazon S3 delivers a strong consistency and for basically all applications. So you can run without any issues this type of analytics workloads.
Awesome. And again, if anyone else has any questions, feel free to put them in the question and answer box. But I see another question, and that one is, okay, this one's a fun one. So this will go for both of you. Are you a cat person or a dog person?
Wow. Jorge, you want to go first?
I have a dog, so I guess I'm a dog person.
I have 2 dogs, and they're right behind me right now. So I am also a dog person, much to my wife's chagrin.
Got it. Okay. Awesome. And with that, we'll take one quick look to see if we have any remaining questions. I think we may have. We'll work our way through all of them. Again, just so everyone, oh, go for it.
Oh, I was just gonna plug, if you're interested in trying Dremio plus AWS, we have coming up in a couple of weeks a special gnarly datawaves edition, stand up an iceberg data lakehouse in 60 minutes. It's going to be after, I think, our regular gnarly datawaves session, but we will be providing AWS resources and guidance so that you can learn how to step-by-step stand up an AWS environment and see Dremio on AWS in action. So take a look for that. We will be sending out registration links. Registration's pretty limited, but we're gonna try to accommodate as many people as we can. So definitely try that out, and of course reach out to us if you want a demo or to continue the conversation about your modernization project.
Awesome. With that, Jorge, is there any resources you'd like to point anyone regarding today's conversation?
Well, in general, the AWS Big Data blog is a great resource for anything analytics. I will also tie up the APN blog within AWS. That's also a really good resource, and we have some blogs actually co-authored by Dremio and AWS, so you can learn more about the integrations.
Awesome. Okay, so again, this episode will be posted on Dremio's YouTube page at the dremio.com. YouTube.com/Dremio, and on the Gnarly Datawaves podcast, which you can access from your favorite podcast tool. You'll be able to see the video version from Spotify. So again, if you really want to watch this episode, you can watch it there. Or if you want to watch previous episodes, you can watch them there as well. And again, we have several episodes coming away on all sorts of great topics. So make sure you keep tuning in every Tuesday. And again, if you can't make it live, make sure you subscribe to the podcast or subscribe to the YouTube channel to never miss a Gnarly Datawaves episode. But I just want to say thank you one more time to Jeremiah and Jorge for joining me today.
Thank you
so much, Alex. Thanks everyone for joining.